drawings in network analysis. And so for my assignment, I'm a big Game of Thrones fan, and I've recently right before this class, I ran into the network analysis for the entire Game of Thrones series, or A Song of Ice and Fire series. And it was pretty cool to see those relationships kind of like displayed mathematically, and because I'm such a fan, I've read the books multiple times and I know how intricate these networks are, and so it's pretty cool to actually be able to see that expressed mathematically and seeing those connections exactly how I expected it. Like, um, for instance, Daenerys is a major player in the game, but so far in the five books that are published, she's very isolated from the rest of the cast, right? She's all the way on the other side of the world, and because of that, we would expect her node to be represented in that way in any graph that we kind of like visualize this in. So yeah, so this is kind of like why I picked this data set. This data set specifically for book three, A Storm of Swords. And A Storm of Swords is kind of interesting because George R. R. Martin decided to kind of like split the series at this point. So he was following like half of the world and focusing more on some characters than others, and we're kind of gonna see that as we explore this here. So I was able to get the data set from GitHub. It I don't see the link here, but I'll include it in the assignment drop off. And then so the data set comes in two CSVs. One is the node CSV, which has the names of each node or each character, and then the relationships between them. Two characters are considered to have to be connected if their names appear within 5 words of each other in the text. That's how the authors of the original data set calculated the connections between characters. And so we do also have an edge data set that takes advantage of this and also um, has weights associated with it. So did I run this? Let's run this. All right, and then we're gonna import it. Okay, did I run it? Come on, V. Yes, this shouldn't take so long. Okay, and now? All right, there we go. Not what you like to see errors when you're presenting. All right, and then so just double checking that it's there. We're gonna just print the heads of of each data frame. Yeah, exactly what we expected to see. So our nodes just has the names, ID, and label. Or in this case, they're identical. And then in edges we have the source node, the target node, and then the weight between each other. And that's just how often that relationship is expressed between them. And like if we look at this, this kind of makes sense, right? So Maester Aemon is the head maester at Castle Black for the Brothers of the Night Watch. So he has relationships with everyone, but Samwell is his right hand person, right? It's like his steward. So it's pretty much his like assistant or executive assistant. So it makes sense that while Maester Aemon has a relationship with Gren, who's another person that is at Castle Black, because Samwell is so closely related to him as his executive assistant, pretty much. This weight is representative of that. So that's how often they are interactive with each other in the book. So that kind of makes sense there. So yeah, so it looks like our data set is in, and so far we make the data make sense to me. Okay, okay, I kind of explained this already. Our edges are weighted. Yeah, and it's how often. So it's aggregative or additive, and each time that two characters appear within 15 words of each other, it's considered a point. So that's how those things are added. All right, so we're gonna initialize our our graph using network X. So that's what this code block is doing. And again, we are taking advantage of the weights. All right, and then here I'm just gonna kind of like draw uh draw the graph. So I did want the graph to be representative of how important a character is, and I thought that the most basic way to do this was just like take like a take into effect just the node, like the total weight for a node, like how often there's interactions between it, and that we like because of that we would see, oh, okay, this node is super important because it has all these other connections, and those total weights account for this amount. So I'm trying to map that to the node size, and yeah, so let's see what this looks like. Okay, did I not run this? Thought I did. Okay, and let's try again. Pass is not identified, is not. Sometimes you comment stuff and you forget to take it out. All right, cool. So that it works now. And okay, so what I wanted to happen kind of happened. So from reading the book and having an intricate um, knowledge of the series, this is a book that Tyrion really comes into his own as a main character. And because he's at King's Landing and he's like the hand of the king there, his he is a central part of this book. So definitely makes sense that Tyrion's name is the biggest here. And then we see some of the other really big players. We see Sansa, she's starting to come into her own. We see Jon. Jon is beyond the wall at this point, but he's still a constant figure. And then we see other people as well. Sam has stuff going on, and then Robb is one of the Rebel Kings at this point. Him and his mom Catelyn are maneuvering and doing some stuff. I'm not going to spoil too much for you guys if you haven't read the books. But yeah, this makes sense. Like I'm seeing some of the big characters represented well. So yeah, that was pretty cool. I would like a little bit more control of how I space things out. Oh, great. So this is that thing that I was talking about, right? So Daenerys is definitely a main character, but Daenerys is not close to the other characters, and neither is Jon, right? Like Jon is pretty isolated from these guys here who are in the heart of the kingdom, and so is Daenerys. Daenerys is on the other side of the world, and Jon is like think of Jon like being in Greenland while everyone here is in North America, and then Daenerys is like in Africa or Asia, right? Like on the other side. So it's pretty cool to actually see that represented from just a simple data set. So the tool is really good at kind of like mapping out those relationships. So that's pretty cool. And then just to explore some more, some of the like uh, metrics that I printed out are the diameter, so the total number of nodes, right? The shortest path for nodes to get from one side to the other, and that's 6, right? So that's our diameter. There's some definitions here. Total number of nodes is 107. Our total number of edges is 352. So that means there's 107 characters and 352 different or unique relationships between those characters. Okay, and the average shortest path length is 2.9, so almost 3 nodes. That's like how short. That's the average for the shortest path for this data set. And then just to like kind of like out of curiosity, I kind of wanted to just see like the degree of centrality for my favorite family, which is the Stark family, and then my second favorite family, which is the Lannister family. Yeah, and this is I know it's pretty straightforward, but hey, Starks are the Starks and the Lannisters are the Lannisters, and they both kick ass. So yeah, so we're gonna run that, and here we see that that the siblings all have like a similar rating as far as it comes to centrality. A 0.24 about 0.24 degrees between Jon, Robb, and Sansa, and then we also see Arya and Bran and Caitlyn also kind of like important, just a little bit less than these guys. And then for the Lannisters, we see Jaime, Tywin, Tyrion. Tyrion absolutely crushes everyone else, right? He's like 10 degrees higher than the second highest character in the data set. So as we can see, Tyrion is focal to the entire network here. And then this was just me exporting this so I can explore it in Grephi. And then this is the graph that I was able to draw in Gephi after I did some other like statistic calculations on there, which was pretty simple. There was no coding. You know, you just hit run on their functions and it does it for you. And after you do that, then you could go and play around with the graphs and this is the one that came out. So yeah, I'm really happy to see like those relationships the way that I expected them. Daenerys is definitely isolated. Jon and Bran are isolated as well as they're to the north of the continent, while everybody else is kind of like clustered in the middle. And then we see even a little bit more like of that separation. Like Stannis is in between. He's like fighting for the central of the kingdom, but at the same time he's making connections to the north, right? Because his army got decimated in book 2. So he's trying to make new connections with Jon. He's trying to get Jon's army and Jon's backing. So he's kind of like in between because he's fighting these guys over here, and then he's trying to make friends with Jon up here. So the graph is actually pretty cool, and the network was really fun to play with. I'm looking forward to kind of like diving deeper into this and just getting better at manipulating the data in Gephi and also making my own graphs in Python. So yeah, thank you for your time.